Hello, and welcome to another video. Whew, it's a little chilly in here. Got my little heater going, but my docking station has finally warmed up to the point that the sound should all be working. It's kind of like stuttery before it warms up. It's kind of weird, but it is quite cold without a heater. Anyhow, welcome to another video where I'm going to talk about the daytime protocol. So this is the little protocol that we've been implementing over the weeks, I guess. Well, not weeks. So I think I can run this like this, or no, like this maybe. I wonder if it's currently running. So if we search for 1313, do we have something? Yeah, I wonder what I've broken actually. And like how were we running it? We were running it like this. Huh. Well, anyway, so I've broken it. Oh, that's what's happened. It's kind of, I don't know. I've got to like back up from restore this thing. But in doing so, it kind of doesn't know how to handle binaries. I should probably check up on that. And I wonder if that did it for all of the untracked files. Should have done the -LA at the start. Yeah, interesting. Anyhow, so if we just go in and guess we need to do that to make the server and do that to make the client. And now if we run the server, yay, we can do demos. And now if we run the client, for example, and try and do it, oh, I don't know, that's a few little things. We've got, what, 100? Oh, it's kind of hard. We didn't want to push that button. I wanted to push that button. So this is 1, 2, 3, 4, 5, 6. So 10 million. How long does this whole thing take? And I guess we can have a little look at the top a bit more. Yeah. And we can see FFmpeg is going hard. I might put it down to per core so we can kind of see slightly different numbers. So we can see here that it's not really doing too much. I guess FFmpeg is taking over. But I've only got one job running on the server, so we can kind of make this a bit more multitask. Now, I was doing some experimenting another time. Can't recall when, doesn't really matter. There's a thing. Did I get it? No, I don't think I did. RFC, that thing, RFC, not that one. Oh, not that one. I want to go here. Cool, didn't leak too much. So in here, I potentially might just go through the code that I had kind of changed. There's a few different things that I did. The client, I've kind of lowered the number of max events for now, might bump it back up, but while the server can only handle so much, it's kind of pointless. So here in the server, we kind of like make sure that we don't like get more than, like basically make sure that we can fit in the FD set because we're still using select. So I think this video, I'm gonna still stick with the select, but I'm gonna add in some what do you call it, status, so I can see what the server and what this client is doing, because at the moment I currently am hoping that it's still doing the right thing. But it would be kind of interesting to see how many like active connections there are, how many, like all sorts of things. How many active connections? How many, like, how big is all the maps and the arenas and whatnot? And I think that could be something kind of interesting to do because at the moment it's kind of frustrating that the server, for instance, so we'll start off with the server because I currently have it going down there. And so currently, where are we? So if we start at main, currently our backlog is potentially not enough that we can kind of do this, but our max events up the top should kind of help with that. So what I want to do is we have two ways running this. We either run it in a forking mode, in which case at the end of this fork, we're now doing a bunch of waits. Now in wait, we can actually wait with a timeout. Is that correct? Time. Ooh. Time out even. No. Yes, so this is we do this W no hang, I believe, and then that would probably says it all the way up here. Return immediately. So I guess we check if something's returned, and if not, we do a thing. But then what is that thing going to do? I thought, when I was thinking of this, I thought that wait had a timeout. Like, why does it not have a timeout? So what I can do is, I guess, do I could potentially do a read on a thing. So there's a few things that I could do. So there's a thing called timer FD, which will this give it to me? Yeah. It's annoying how man pages, like, you know the thing that you want to do, but you need to know the exact command. You can do like man minus K or hackers, and that will do it. But yeah, so what this timer FD does is basically makes a file descriptor, which will basically give you some information every period of time, which can be kind of useful. As like a sleep, but when I think this isn't what I want for here, but it's potentially what I want for in this handle child, and the handle child we just will then have like a little status pipe as well. What do I want to do here? So handle child, we currently pass in the listen FD. We could potentially pass in potentially a context is good at this level, but we could also pass in a timer FD, and it could just be -1 in the forked version and not -1 in this version. And then in here, when we do the select, we can check for if FD is set the timer one as well. But yeah, I guess if we currently are forking, we can kind of just do this on the wait. So I guess in the wait, I need to give it some options. So wait is equivalent to -1 W status and 0, but for 0 we would do W no hang. yeah, that's what we want. So what would we do? Wait, PID, and this was -1, and this was now going to be W no hang. Is that what it is? Now, this now means that it could return uh, -1. So if we look at return, so it would be -1, but I actually want errors. Do you have? Yeah, so errors will potentially return E again. It's kind of like a weird term. Returns 0 on success, or does that. If that. So we might just get 0 as our PID. So I guess if weighted equal 0, this is meaning that we haven't actually done the thing. So potentially I want this to be not equal to 0, and then all of this we can kind of get on here. And like, I don't know, at the start of well, no, so like if weighted equals 0, we kind of want to do an I minus minus, and then continue, because the way this loop is set up. But I think I just want to do a while true, but potentially I can do a slice t woken, and we can set that to be 0, and then while woken is less than what count, and do something like that, and then we don't need this I thing. And then if we have here, we probably can go woken plus plus. So we have woken something up in that case there. This is kind of looking almost kind of like a well, like I do kind of want to break there. So if weighted is 0, then we probably want to do a thing. So we can probably just do something like this and get rid of that. So if weighted is 0, we want to print out some statistics, I guess. So fprintf std error, and we kind of want to make sure it's at the start of the line, I guess. This has also been going on a long time. Potentially it was almost about to finish, but if I did 10,002, that should probably, yeah, that goes a little quicker. Well, so I guess this 100,000 should be around 9 seconds. But I kind of want to test that again, but doing multi-threading down the bottom. So there was, so if I do like 8 threads that we can do and maybe connect on 4, we can see if this is like a little quicker. It is a little quicker. There will be a limit where it becomes less viable to kind of do this. Like if I look at VTOP, we can see maybe if I do a bit more, so this will probably run for 30 seconds, we can see like it's not actually going full bore on each CPU that it is kind of taking up. FFmpeg is kind of there, but I suppose the whole system is showing that it's 100% CPU, so I don't know what this will sound like, but yeah, interesting. So I was thinking 30 seconds, but I might have let it go a bit too early. Anyhow, what do I want to print out of here? I kind of want to do an escape code that will take me to the start of the line, if that kind of makes sense. And I'm going to overwrite whatever is currently written. So how do I do that? That needs some escape code. So what I'm going to do is maybe look this up. So ANSI escape code. ANSI codes. There's like a nice little list of someone has worked it out. That was 40 seconds. Or it's. I mean, this has some stuff on. So in here, I want this one. Yes. So here we can. We'll see if we can make that a little darker. So here we can kind of move the cursor up and down, move it like to the end of the line. So what we can do is that's how many cells we can do. This moves it to row column. What I want is just to move to the beginning of the start. Well, this might be it. So array is part of the line. So clear cursor between the line from beginning. No, I kind of want to move the cursor as well. How do we do this? I guess like maybe just even a carriage return does something. So if we did something like this, and we probably need to do a flush of std error. I just want to see if cool, that is just that. So that is currently printing test on every, I don't know, it's too quickly. So I think I do want to go back to the timer approach. But I don't really want to have it open for everything. So perhaps at this point here, we would do a timer, and we can make this a timer FD380, and we'll. Oh, it's grade 1, isn't it? No, what am I to do? Oh no, it is just this. Cool. I was thinking of another syscall there. They just made it the next one because that's what it is. So I kind of want clock monotonic, which is it just keeps on going up. So what we can do here is clock monotonic. And what was the second parameter? The flags. So the flags I want. I don't want non-block, I guess. I wonder, can a process ID be a file descriptor? And the reason why I think this is because in not that in wait, it mentions there's wait ID. It mentioned PID FD open. Yeah, what's this thing? I think this is kind of what I want to do. PID FD open. I'm just finding out new stuff. PID FD open. So with this, we can just give it a. So it's a syscall. It hasn't got a wrapper, but we can potentially do a wrapper if we want, or just do this. I'm happy either way. And we just make a file descriptor that is a thing. This is actually quite good because here what I can do. So we have all the forks. What I want to do is the forks I want really to get made into this. So what we can do is perhaps I do still want to keep a track of them. Because I also kind of want forks FDs. Right. And this is just going to be that's what a file descriptor is. And do something like not that, this one, and that. Do something like this, and then in here, when we do this, we kind of want to do a PID FD open. So this was a syscall. I mean, really, I do kind of want to wrap this. And we already kind of do this in, oh, we don't have Futex in here. Do we have Futex in client.c? We have a Futex, which we do this sort of wrapping with it. So if I go back to here, like, I don't know, we can go somewhere. Here, and here we can change Futex with what I was doing PID FD open and do something like that. And this was PID. Oh, I love how Vim is like that. So other editors, this is like spread over 2 lines, but all I have done is CI in between brackets, and it just worked out where I want to do it. And it's exactly the thing I wanted to do. So what other thing did we need? Unsigned flags, and it's unsigned in, or unsigned and flags. All right. So if we do this, then this is. So this isn't. I want to do that, but what I can do is when I was here, I can just go to the end of it. Can't really do that on. Well, I can. PID and flags. Cool. So that does this. So now if I search for this, yeah, I did still have it. So we can go forks FDs, or ID, equals this whole thing. I think I want to kind of store this in a thing before doing this, and then like maybe find that and then do that and do that. And so now I want to get the child and 0 for my flags, and like have something like a 50. Maybe I don't care about that. So we can do something like that. No, I kind of do. So if we go back to this, I don't really want this. So if FD not equal to -1, we need to have like an FD set. Set, and this, we can do this, but we also need to do FD 0. Set. So, I mean, this is making the assumption that we're still using select, which we are at the moment, but that is what it is. So if FD is not equal to 1, we can go FD set. And does this like creates a thing that refers to a thing file? What happens if you read from this file descriptor? So we're basically doing the same thing. So there is like a potential of it disappearing, but that's all right. Yes, so readable, perfect. Cool, and then we'll do FDs and do set. So we'll set that, and we'll also set it in our little array. So if this happens, at this point here, we can kind of do this instead. So we can actually go and selected equals select. We need to know the last number. I guess we need to do a cheeky. We're not going to have like heaps, but we can do a cheeky lines. Let's say can't I last. And if forks FDs negative, if that equals not equal, well, if it's greater than 0, then we can we need last, and it can just start off being 0. And if this is the case, then I kind of want to get FD out of this just to avoid the constant lookups. Because we're I've lost it. So this was for FDs, and it was I. So if FD is greater than 0, and if FD is greater than last, really I just need this check, and then we'll go last equal FD. So we'll do a quick little loop there to do that, and then here we would do a select, and what is that? Last plus 1 and read FDs. So last plus 1, and then read FDs, which was fork set. Cool, and then that should return us a thing. And then we need like a few nulls, null, and that many. Cool, so if selected equal -1, something weird happened. I kind of want to like almost, yeah, I think this I want to just kind of say and then do a breakout of this, and then here I just want to do another loop, but it should be cheap. If it finished, if it already finished reading everything, then it wouldn't need to do this. So I wonder what you read out of this. PID FD open, PID FD open. Let's finish reading. Readable. Nothing can be read from. Right. So it just. Right. Cool. So at this point here, now we can wait for it. So at this point here, we basically need to run this code. And like kind of for we can say it's that now. I equals 0 and I is less than selected. We can kind of just do that many because there might be several children finished all at once. And then if we get here, we can kind of close off. This is kind of copied code, which I could fix, I guess, but yeah. Cool. And at this point here, we kind of need to. We get this, and we now need to go forks FDs, and this is going to be J, and we'll just set it to -1. But we probably need to close forks FD, and I kind of want to get it out because I'm needing to do a few different things. And so this can just be that, that can be that. And so we're going to close it. We're also going to FD clear and take that out of, gosh, what was it? Fork set. Except that is going to have that. We're actually going to go forks FDs. j equals -1. Need to make sure that we set the right thing. Otherwise, it'll keep doing it. Because up here we get the last. Really, I could have a I could have a NFTs. I could have a last there, which is set to 0. And if last is equal to 0, then we do this. And I think at the end of this, we should do another check if last is still equal to 0. Maybe we'll make it a -1. No, we'll make it 0. If it's still equal to 0, then I think I want to do a break out of here. No point selecting on it if it doesn't exist. And so here, I think here, if FD equal last, then we want to make last equal to 0 again. So it will pick up this and do that check. But if you didn't get the last one, then the last is still valid. Cool. And then we'll do that twice. Cool. So with all of this, it doesn't really we need to have 2 sets. Variables, and this is going to be equal to 4%. And this is going to be readables. So we'll get it from the original set each time. And we'll do this. So what we need to do to include that? Syscall and unis did. No, that's that key. No, that key. Include. Was it that? I can't recall if it was that. Yeah, it was. Cool. So this fork FDs we also need to keep track of. So that was up here. This is just an insta forks FDs. And so at the bottom we should probably free it. Cool. So what type? What were you? It was just an int. We'll call you an int then, buddy. And cool. So if that is the case, so now the server should hopefully just work the same as it was. So if we run that slightly shorter one, should do something. Yeah, that looks like it did something. Still got the right number of things. So this didn't actually add any, what do you call it? Timers. So what we need to do is make a timer, timer FD. So this is going to be a timer FD V8. Is this the one that we need, like a 2 thing? No. No, I was doing it just before. I remember. Monotonic, and our flags, we just want that. I suppose we want this to be we now just kind of want it to be non-blocking. So TFD underscore non-block. So this can be TFD non-block. And I think that means we also want this, oh golly, where do we do it? This one, also PID FD underscore non-block. No idea why they don't, well, I kind of get it, but PID FD non-block. So there, now they're all kind of non-blocking, and that's what we want. But we kind of want to do this timer FD as well. Now, it's only really used, we do need to kind of keep a track of it, I think. Timer FD, and it can be -1 to start with, and listen timer, and do that everywhere. Cool. So in here we make it if it is equal to -1, then like I don't know whatevs. We'll just do a pair timer FD reacts. And what we do up here? Did we? I think I want to do a pair if it perhaps FD equal -1. Goodness. We'll do a pair of PID open just so we can see if there are errors, but we don't really care about dealing with them. So if it was not the case, we can do an FD set of timer FD, and we can add it to forks set. It's not really a fork set anymore, but oh well. So we can now kind of do this. And I think that's still the case there. We don't really want to keep breaking on the timer when all the children have ended. And then down here, we also want that one more. And at the end, it will still collect up everything. But in here, we might have woken up a timer. That is the case. We should probably do something about it. So if in here we want to check if air no equals E again, I think that was yeah. Yeah, so I think it's potentially what we want. Or it could return 0. Yes, that's what we want. And is that what we do? Yeah. So if it returns 0 here, this is where we want to break out of this loop. But that printing might be done here. So here we do if FD is set. We not that one. So if this, what do you say? You still just want the FD at the start. So if the timer FD is set on the fork set, actually no, if it's set in the readables, then we are going to do some timery things, and then at the end we'll do this. But we can probably say selected minus minus, and then that would kind of cover that loop. And then this is probably unreachable. I feel like this would be unreachable now, but we've got the no hang. In fact, I might even say unreachable. Rated wait PRD called when nothing selected. No, something like that. I don't know. We shouldn't be getting that case, I believe, because we now do this. Now, so if this is the case, we can do some thinking. Now, we actually need to kind of do a bit more with the timer FD. We need to set the time and whatnot. And so this, I believe, gives a little example. So what's this now? We get the current time. We don't really care about that, but um I mean, this is kind of what we're wanting to do, but we want to select on it. I did this in another point, but what we want is we want to struct by timer respect, and we give it an IT value. Well, in fact, it tells us in the things. So IT value is the initial. Um, and then there's IT interval as well. So I think we just want IT interval. No, we need that first one as well. So, iTimer spec is where that is talked about. So iTimer spec. So we need a iTimer spec. So struct iTimer. I need some water. I just got a little head thing. So I'm a spec, and so this is going to have two fields: a time spec interval and a IT value. So IT value is when it's going to first go off, and we can say that it's the struct time spec then has more things on. This man page actually gave a bit more kind of, well, I suppose down here it kind of showed the fields that you have. You can have TV second. So I think I might, and TV in second. So TV sec. What I might do is just have it as every second we'll give a little update. So that is the case. And then we go timer FD set time. Is that the case? Yeah. And then we go FD flags. Now, what are these flags? Set time. Flags. We can. I don't care about any of those flags. And then we can get the old value if we want, but I'll just show it as null. So we give it a file descriptor, flags, timer, FD, our flags, our pointer to our spec, and we don't care about the result. So then this, we kind of want to see if it failed. So if it is -1, we can do the error. So this is timer FD set time and failed for whatever reason. Otherwise, we can kind of set that in the set. Actually, if it failed, I kind of want to do a close of timer FD and then timer FD equal to -1, just so we don't actually try and do a thing. So in here, this weighted we don't care about. This we actually just want to go back to doing a weight and something like that, and then do something like this. But yeah, our status should be getting printed in here. So we can potentially show a little thing. So we're doing carriage return to take us back to the start line. And we can just go, I don't know, just go status. And I think we need to do an if flush as well. But potentially we can turn off the need for flushing this. Golly, you can do it on null and it'll just do it on everything. Did not know that. Anyhow, why is it set buff? I think set buff is kind of what we want to do. And we kind of want to say it's unbuffered. We just send it out as we do it. Because that would save the additional flush, I guess. So if that is the case, we set buff, and what was it? Set buff. Set for unbuffered, we don't care. Cool, I think we can just do this and cool. So we actually want to do that down when we do the timer FD. So if that is the case, we should probably do a set v buff. So the stream, then the buff null, then the mode, then the size. And the mode we want is underscore ion buff. So the stream, the buffer, and underscore ion buff. That looks good. And was there another one? And a size, but our size is just going to be 0. And then if this is equal to, we'll do, if it's not equal to 0, we'll do a little p error and set the buff. And I think we just won't care about it. Like, if we can't do this, maybe we'll do status buffered equals true. And we can start off with status. This is getting like a little spaghetti, but oh well. And then if it is status buffered, we can just do that. Cool. It doesn't know about that. FD underscore non-block. Where do you define that? So I believe I can probably do a little grep minus n for PID FD non-block and user include. Yeah, but I actually want to do this R in there. And is that doing it? Yeah, so now it should get a sysf. Have we not included sysf? Did FD potentially need to include that? That already just defined perfect. We don't need to do that. We need to do sysclimber FD. Climber FD. That for both of them. Cool. So now hopefully I should get a status that is updated at some interval. Hasn't done anything. Not really a good sign. We'll see if it can run things. Make sure that we're actually compiling the server. Yeah. All right. So why didn't this pick it up? I'm actually kind of interested why that didn't pick it up. So when it is doing multiple things, we can run this, and if we, I don't know, break and fall, we can run until there, we can get the layout source, we can thin from there, we get a thing, but we can now delete that breakpoint. And now we can kind of just step through this and maybe do a display on forks set. Display one things. and also display of like, can we do just I kind of want there will be 4 of them. So we should get 4 of them set. And that should be enough. Cool. So we have a timer. It's not 0, so every second it should tick over. And it's non-blocking to start with. Can we do this? Yeah, cool. So this should set and fork set. Yeah, that changed something. Display last. Potentially timer FD will always be last, just because of the way we did it. But yeah. Yeah, so I think this check won't quite work. That means that this thing will never really hit as well. But we should break out of the loop once we hit them all. Perhaps this should be done every time. And then down here, we don't really care. PQ, PQ. Just the 4. That's kind of what I expected. Perfect. Just the 4. That's kind of what I expected. Cool. So now you can see it's like kind of flickering. It is printing the status, potentially more often than we would like. And I think that is because it's readable, which means we kind of need to do like a dummy read. So we can do like a what does it give us? I guess timer FD 8. What happens if you do a read? Do you tell me? Uh, all right. If signed 8-bit integer, you in 84, cool. And that's number of times it has gone over. That's kind of cool. So I guess we can just give it a UN 84, read into that, make sure that it is read, and just ignore that. But it is a uint 64 T overrun. and then we'd do a read into from timer FD into overrun, and it'll be the size of overrun. And this will do that. And like, I think if red equal -1, that's kind of something we should notify ourselves of. Overrun. That's not that timer. The and I think at this point here, I want to do timer FD. Like maybe I don't. Like, I kind of want to unset it at this point. Which means before this, we should do a close of timer FD, and we should probably also do an FD clear of timer FD and readables. Apologies if there's any noise. The neighbors are doing some stuff. But I believe it's not. Yeah. I've got a tool that kind of tracks my noise. Wasn't that? I've finished them both. Right. I might have to finish the stream at some point, but hopefully now I have a status line that's not too flickery and it goes every second. So here you can see it is kind of clearing every second. It's not actually clearing though. So what I kind of want to do is now clear it, which is 033, and this one told me. So we want to erase in line, and we can just ignore it. So CSI K. So CSI is that, and then it was uppercase K. Yeah. K. So if we do something like this, and perhaps I'll just make it obvious that that's doing that. And now if we, well, it's doing a thing. If I got CSI wrong, CSI escape, then that's sort of a bracket. I've got the brackets wrong. And do something like this. Cool. So the timer I kind of want to start straight away, I guess. But I think if I set this to nothing, it will never go. So I think I want to set nsec to 1. It will just fire off a nanosecond after I create it, and then we get a kind of thing there. And you can see here, I can type and it clears the line. If I go to the next line, it will do that, which could be handy if you want to be like, I want to know what that status is now, and then you can be like, that was interesting. Whatever interesting is, but cool. So all of this is doing some things. This is only for like multi-fork. The single fork we haven't yet done, but what I can do is maybe make this a bit more reusable. So if if we do this, want to kind of yank all that, and kind of yank all that there. So if this is the case, we can now go timer FD and like maybe pass it the status buffer. I don't really like passing in more things, but what I could do is make this underscore and then not down there. Uh, yeah, that one. Down here, I can do a hash define of that with the underscore version, underscore that, and we can just pass in the listen FD, and we can pass in -1 and true what is. We can do false. It's minutely easier for a computer to do a 0. Minutely. Anyhow, so if we do this, we now have a timer FD and a bool status buffered, and that's what we want. And then down here we have like a bit of copied code. So in here we don't actually have this FD set. And that, but we do have a timer FD. And then handle child. So in handle child, if timer FD is not equal to -1, then we will do basically this, and then if timer FD is greater than last, then last equals timer FD, perfect. And then this would be timer FD. And so now here in this, we now just need another little check. If FD is set on the timer FD, we can now just go show status and like maybe pass in the context. And that shows status will be doing this stuff. So what do we need in this? We need kind of the timer FD. We also need pointed to where pointed to where we are. And that's kind of it for now, but we will need more. But yeah, now we can kind of yoink that code, and then up on there. After a bunch of things, we can do a void. What was it? Show status, yeah, and we passed in a timer FD, and an FD set read rules. And that was all we did at the moment. And then all of this stuff would be down there and do something like this. And like maybe that can be do something like that. And now here, whenever we do show status, we do an if this. Oh, fat throwing everywhere. If this is equal to -1, then we will do that timer fd equal to -1. And so this, at the moment, we can just pass in the timer fd and at readables. Do something like that. And if that is the case, we'll then do this. Something like that. Now the show status, we're clearing from the thing. So this we actually want to be next read. In this we want to be forks FDs. And here we, I guess, need to have a status buffer. Actually, so here we what we're doing, status buffered. Cool. This it didn't like. Oh yeah, that is correct. That needs to be set. And this was that. Cool. So now, if we run this, we get a status line printing if we do with 4, and we also get it with 1, and it gets updated. And just to check that we can kind of still interact with it, we'll try and do some things. Cool, we still get that with 1, we'll try with 2, and we still get 2. And this printed some errors actually when we did that. But when we did 1, it was fine. Interesting. Yeah, it's kind of interesting. So timer FD read. So that was happening in show status when we read on, and it was only happening in the second one. So weird. I kind of want to break out the old debugger for that. So we can run for. So if we do a break on show status, for example, it will happen quite a bit. All right, well, we need to. We need to kill them. BQ. Yeah. Show status. So we should kind of hit that every second. That is happening in the other one. It's interesting because it comes through as -1. It was like one of those bugs that could have been doing anything. Right, so now does that, and like we're still printing the status. We do a 1. Still kind of printing the status. Perfect. So now the show status is a kind of factored out into a point that we can start making a status that is more useful. Like, I don't know how many connections you have at the moment. But I think for now, I was kind of just showing how you might shoehorn a kind of status line into this kind of like event-based model where you're selecting on everything. So currently we're selecting on everything. Now all we're doing is just selecting on another thing. So I don't think it slowed me down that much. So if we do like a get stash, it potentially will now because I had all that changed code and whatnot. So this actually might be quite a bit slower. Or it might just not work. I don't know. I think I might stick with that. I forgot to commit at the start of the stream to kind of see how many we had going on. It is what it is. I'll commit now because I kind of have the rough outline of things, but perhaps I'll get some of the stuff that I know was done last time. I actually want to. Can we go back? Ah, so I don't want any of that. So what did I do there? Does that look roughly the same as what it was to start with? Now, did that have any timer FD in it? It did have some timer FD. So what I want to do is get get restore staged minus P. So anything with yeah, so this we can potentially split. I don't care about that. Care about that. Don't care about that. Don't care about that. This I want to unstage. That I don't care. That I don't care. This I also want to unstage. That. And I think none for the rest. So now if there's none of that in there, so now we can kind of get commit that is at the start of stream. Fixes. And now I think I can potentially do a git stash and perhaps do a cheeky compile. And we can just see how long it was with that. So I think it didn't really slow anything down. So now if we pop that, do a little recompile, start that again, and run that. Yeah, so it's no real change, but now what I can do is add in all of this kind of status stuff. And what do you call it? Skeleton of the status in a child. And like, I guess maybe it's possible to. Actually, was that in child? We just handle a child. Yeah, it's not really in child at all. In server. I had a quick glance in the diff and it said child, which is correct because it's a child of a fork, but that's not really what I meant. So in client.c, we have I guess similar kind of structure that we are doing select. No, we're doing poll now, are we? Yeah, so here we're doing poll, which is a little different, but similar idea. We're just looking at a file descriptor. What I want to do is potentially make the server do poll first before I go and put. Oh no, it's kind of useful seeing in the client a status. So I think next time I'll look at putting a status in the client, even if it just says status. That's the framework for now. I can put more stuff in, and it is still reactive. There's also the other thing that I want to be reactive to is interrupts at some point, and potentially the status could be driven by an interrupt rather than a file descriptor. We can work out things as it is, but yeah, for now, I think this is good. But interrupts could be good in the future. That you could kind of do a PQ. By interrupts, I mean signals on Linux. But you could do something like sig like you can have a few signals, but like you could do like a sig user one, which might mean reload everything, or you could do a sig user two, it could mean something else. And it could be that all the children can have like a pipe to the parent, and so like you can have into communication between that. But that's potentially thinking a bit further afield. But for now, I think this is good. Did I add everything? I did. Cool. And it wasn't really. Did I commit everything up? I feel like, yeah. So maybe I want to RM Gmon and error out, and all these tests. Yeah, they're all that. Or maybe do that. Yeah, that's looking good. Cool. So anyway, thanks very much for watching. I see that it's weirdly interesting to some people, me doing a very basic protocol. Like all it does is print in the date. In fact, people were more interested in making the client to do it, so I don't know. But I guess my whole point is how to make stuff like this more efficient, and maybe turn our paradigms on our heads and make it more event based, and how that can still be quite efficient and do things. Like now I'm just a single core and it can do like quite a bit of stuff. Anyhow, until next time, see ya.